CSAP installations begin with provisioning of one or more hosts. These hosts can live in AWS, on customer premises, Google Cloud, or any other provider. The current installs have been validated on the latest versions of CentOS and Red Hat versions 7 and 8. As there is limited coupling to the operating system, support for other Linux variants could be done based on demand. Command line switches to the installer and support for installer templates via the CSAP autoplay APIs enable teams to build one or more default environment templates and then leverage them for a seamless install. Typically, only the first CSAP host in a data center is installed using SSH. The steps for a new data center are covered in the new application setup guide. The installation we're going to follow today will leverage the CSAP command runner and the CSAP host install template. To get started, we'll log in to the application portal, select the host tab, and then we'll click, once the host portal is up, we'll select command runner, click on library, filter by the word install, and we'll select the CSAP host install. It's worth noting that once a team has a consistent set of parameters they wish to use, you might save these in your application definition folder so you have some ready-made templates. For today, we'll stick with the standard generic CSAP host install. Now we can go through this script in detail at some point. However, for today, it's worth understanding that the remote installer uses SSH pass to run an array of commands remotely. This is encapsulated inside of a CSAP bash helper function called run remote. If we open up the install commands, you'll note that these commands are remarkably similar to the commands run in the CSAP new application setup. So to install on a single host, we'll just go ahead and update some of these variables. So we'll start with specifying the host we're going to install. And in this case, instead of installing what's already on the host, we'll specify default to install a simple default application. Then we've updated the password, and that's it. We'll keep all the other parameters consistent. Currently, this is set to run in the foreground. If we were installing multiple hosts, we'd probably set it to false. But since we're going to run this through the console and we're only doing a single host, let's go ahead and set it to true. And with those parameters set, we'll go ahead and click on Run. You can see that the installer starts by verifying access to the host and ensuring that the root password is correct. CSAP includes some pre-flight tests, so if they fail for any reason, you can always specify the skip pre-flight parameter. In this instance, it looks like it's going fine. In this install, I'm actually using internet repos, so the verifying repos and packages step might take 30 seconds to a couple of minutes, depending on your speed of access. And so usually within 30 seconds, you'll see that the installer has completed, and it provides a message suggesting you to open the port. And now we can see the login page. The default installation package uses in-memory user ID and password. So there's no tie-in to LDAP or any other identity management system. This is a system that's brand new, and we didn't get in here quite quick enough because all of the services are already bootstrapped. If we had come in here a little bit quicker, we might have actually seen some services in the backlog. The CSAP default in cluster is named with a reminder to update your application name. If we look at the services, we can see that there's some standard OS packages deployed, as well as a couple of sample applications. To verify this, for example, we can go ahead, open up CSAP demo, and then let's go ahead and just stop the verify service. And then we can go ahead and restart it. By default, the output of the start is displayed. If we hit logs to refresh it, it will default and select the console logs. Now we're seeing the actual output from the service itself. To get something more exciting, such as Kubernetes installed, we're going to leverage the csap autoplay. To leverage csap autoplay, we'll switch over to the File Manager view, open up csap platform, we'll add a filter of autoplays, and then we'll open it up. There's a convenient autoplay called All-in-One Autoplay. If we open this file up, the key thing to note is that this is a YAML descriptor that provides the necessary instructions to augment the csap project definition with the features required by Kubernetes. The key thing that it prompts you to do is to modify the host name to be your target install name. So we'll go ahead and replace all instances CentOS with our target install. With that done, there's no further actions required. Maybe one thing we'll do just to kind of highlight is we'll modify the application to be demo for screencast. That way we'll have another example of modifying an application definition. We'll hit save, go back to the File Explorer, and then we'll just go straight to apply. We get a message saying that the application definition has been updated. And we also get a note saying that we need to reload the web browser. After reloading, the first thing to note is that the application name is called Demo for Screencast. If we go to the Deployments tab, note there's some new unprovisioned services that are now appearing. What csap autoplay did was to take the contents of the YAML file, merge it into the application definition, and then we reloaded the cluster. For example, you can see the new Kubernetes provider and the Kubernetes system services have all been installed as a part of the application autoplay. To deploy Kubernetes now, we have a couple of options. We could go to batch operations, select the clusters, and then hit deploy. Instead, we'll do this individually, just so that we can track what's going on. We'll select services, select Kubernetes provider, select kubelet. A new host will already have the package, so there's no need to deploy it. We simply need to start kubelet up. This will start the installer inside of the csap kubelet package. The csap Kubernetes install includes the repo setup as well as the actual yum install of the OS package. Now in this instance, we actually got an error, and if I scroll up, it actually gives me a message saying that Docker was not actually available on the host. That was my bad. I should have ensured that Docker had been started first. If I switch back to services and go to base OS, we'll see that the Docker package is added to the csap package, but it wasn't actually installed. So we'll go through a similar process of selecting Docker and clicking Start. This will install the csap Docker package first. The csap Docker package also includes some sanity tests. So you can see here, we actually install Nginx and then use curl to hit and verify it. Now that we've got Docker installed successfully, let's go back and complete the install of Kubernetes. I went ahead and did a clean before doing the start, so this is just going to start from scratch again. One optimization step in the csap Kubernetes installer is to pull all the Kubernetes images onto all of the hosts being installed concurrently. That way, although we have to serialize the start of the master, we can do the workers in parallel. CSAP uses kubeadm to actually perform the install. Here we can see it waiting to bootstrap. Near the end of the installer, it will wait for Calico to be up, and it will pull Calico, waiting for Calico to be fully in service. And once Calico is up, the node will be in a ready state. CSAP, similar to the Docker package, the kubelet package, will actually run a validation. And so you can see here it's running deployment tests. And we see once again that we have a success message, meaning it is fully available. Let's switch over to the agent dashboard. And look at the status of Kubernetes on the system. So now we see that both Kubernetes and Docker are installed and available. We can also verify availability through the Deployments tab using the Pod Explorer. So you can see that we have a single node system. It has no 9 pods, which are all system level pods at this point. To actually go ahead and do a quick test of Kubernetes, we can open the editor and let's load one of the template samples. So maybe we'll just go ahead and try the Nginx simple. Let's go ahead and we'll hit create. It asserts that the Nginx service has been deployed successfully. And we can see the Nginx deployment is created. And we see the Nginx simple pod has been created. This sample also included a service running on a node port, so we can click on that to launch it, and we'll get the message hi from Nginx simple. We can further extend this use case a little bit, so let's go back and let's modify the deployment. So we'll go ahead and select the Nginx simple. We'll load it in edit mode. And if we scroll down, we should see that message, hi from Nginx simple. And we'll say hi from screencast demo. We'll go ahead and do an update. And it'll take a minute for these changes to be configured. Kubernetes doesn't do deployments instantaneously, but rather it schedules it, and then based on resource availability, it will go ahead and perform the deployment. I saw the events flip, and we can see that the Nginx simple is in the state of coming up. I think it's pretty close. We open up the pods. It looks like it might be ready now. We can flip over to that previous tab and then do a reload.